Hello everyone, welcome to today's session. We are dealing with the composite materials and structure. In the class, we are mainly focusing on the topics under the second unit called micro and micro mechanics and macro mechanics. In today's session, we are going to discuss about the elastic approach in composite materials. We are going to discuss mainly. First of all, what are the things we are going to have in the elastic approach and key aspects in the elastic approach, elastic properties of the composite materials, then what are the analysis methods are available, then limitations of the elastic approach. These are all things in today's session we are going to discuss. First, let's move on to the elastic approach. What do you mean by elastic approach? What are the things we are going to have here? In elastic approach in composite materials involves analyzing the behavior of composites under the assumptions of the materials exhibit linear elastic behavior. It is very important assumption we have to take care for the elastic approach in the composite material. That means that the materials exhibit linear elastic behavior. That is, a Hooke's law should exist. Stress by strain equal to Young's modulus within the elastic limit. So that elastic approach, linear elastic approach will be existing within the elastic, that is Hooke's law will be valid up to that point. Next, in this approach, which is used to predict the elastic properties such as stiffness, strength, composite materials. These are the main properties, elastic properties used to predict in this elastic approach. Then what are the key aspects in the elastic approach? First one is Hooke's law, then elastic constants. Next one is the rule of mixtures. Next, micromechanics, then macromechanics, which has been already discussed in the earlier classes. Then here the stress strain relationships are linear and reversible. As said in the Hooke's law, the stress is directly proportional to strain within the elastic limit. So here it is given the stress strain relationships are linear, as well as it is reversible also. Then elastic constant here Young's modulus, Poisson's ratio, and the shear modulus. They are used to describe the material behavior. Generally, the Young's modulus, general bending strength will be taken care, and Poisson's ratio is nothing but the lateral strain to the linear strain. If you apply the load in the along the axis of the length, so there will be if it is a tensile load, then there will be a stretch in the axis of the length. At the same time, there will be a decrement in the length, decrement in the dimension and the lateral dimension called width also. So these two ratios called Poisson's ratio. Then shear modulus with an angle of an angular deformation will be taken care. So these elastic constants are used to describe the material behavior in the elastic approach in the composite materials. The next one is rule of mixtures. In this composite materials are estimated. In rule of mixtures, composite materials are that properties are estimated by combining the properties of individual constituents like fibers, matrix, and as a whole composite materials. So the properties can be estimated by combining the properties of individual constituents. And analyzing the behavior of the individual fibers and the matrix in the representative volume element like RVE is called the micromechanics, already discussed, and examines the behavior of composite laminates using laminate theory. That is coming under the laminate theory, already coming under macromechanics, which has been discussed earlier. Then elastic properties. What are the elastic properties of the composites? So longitudinal modulus, that is the Young's modulus, is the stiffness in the fiber direction. Then transverse modulus, that is nothing but is a stiffness perpendicular to the fiber orientation or fiber direction. So longitudinal modulus is nothing but the stiffness in the fiber direction, but in the transverse modulus is called the same thing, the stiffness property, but the direction is perpendicular to the fiber direction. Then in plane shear modulus, here the shear stiffness in the fiber plane. Then out of plane shear modulus. This is nothing but the shear stiffness out of the fiber plane, which has to be very much important property in the composites. Then Poisson's ratio, as I said, that lateral strain to the linear strain, how much change in the lateral dimension to the original dimension, that is in linear dimension. Then analyze, what are the methods to analyze? So one is closed form solutions. Next one is numerical methods. Third one is the experimental characterization. In this closed form solutions, analytical solutions for simple geometries and loading conditions. By using these things, the solution can be analyzed. In the numerical methods, boundary element method as well as the finite element analysis for complex geometries as well as the loading conditions. By using these things, these numerical methods is a very important analysis to identify the solutions. Then the experimental characterization, it is a material testing, like mechanical testing, experimental testing, and non-destructive element testing, as I said earlier. Generally, here the mechanical testing and non-destructive evaluation to measure the elastic properties rather than the thermal testing. Then what are the limitations to the elastic approach? One is non-linear behavior. If the composites may exhibit non-linear behavior under high loads or complex loading conditions, then that will be a challenge. It is a limitation. We cannot do the elastic approach for getting the solutions or getting the behavior of the materials properties. Then damage and failure. So elastic analysis does not account for damage and failure mechanisms. Okay. Next one is material variability. Here composites exhibit material variability which affects the elastic properties. But we have already told that we have to have an assumption in the elastic approach. The materials should have exhibit purely elastic approach. So these are the challenge. We have an assumption, but in practical life it is not possible. So these are the challenges. Once again, I'm telling that non-linear behavior is an important limitation to the elastic approach. Another one is damage and failure. They may cause the damage as well as the failure in mechanisms in the elastic approach. Then material variability, since we have assumed that the material will exhibit the elastic approach, so which affects the elastic properties because of the material variability. Next, we can have an elaborate discussion here. What are the elastic properties in the longitudinal modulus? So it measures the stiffness of the composite materials in the fiber direction, told you. Then transverse modulus in the opposite fiber direction, that is perpendicular to the fiber direction. Same parameter, stiffness has to be measured here. And in plane shear modulus, it is also shear stiffness has to be measured in the composite of the fiber plane. Then out of shear modulus, then Poisson's ratio, as well as analysis methods, closed form solutions. Here analytical solution for simple geometries and loading conditions. Then unidirectional composites under longitudinal loading also analyzed here, as well as cross-ply composites. In the closed form solutions, cross-ply composites under in-plane loading. So these will involve in the closed form solutions. Then numerical methods. Here it comes finite element analysis, then boundary element method. So in these complex geometries of, under the loading conditions has to be concentrated, like multi-directional composites under combined loading, as well as composites with complex geometries. Composites with complex geometries or defects has to be analyzed here. And the experimental characterization, mechanical testing and non-destructive evaluation can have to be done such as tensile testing for longitudinal modulus, then shear testing for in-plane shear modulus, shear testing for in-plane modulus. These are the analysis methods generally. Then micromechanics. So a small representative unit cell of the composite material is called RVE, that is the representative volume element. And also another thing is fiber matrix interactions. It analyzes the behavior of the individual fibers and the matrix in the representative volume element. Another one is a micromechanical model for periodical elastic properties. A micromechanical model for predicting the elastic properties of composites. That is help in solve equations by using this failure theory. We can analyze the or predict the elastic properties of the composite materials. Then macromechanics generally it come relates with laminates. So laminate theory, classical laminate theory, then first order shear deformation theory. These are all coming under the macromechanics. In macromechanics is CLT is a classical laminate theory. Here we have to have an assumptions that a linear elastic response and neglects the shear deformation. In the first order shear deformation theory, here it includes the shear deformation and it is very more accurate for laminate thickness. Next one is the limitations. So the limitations is, I told you earlier, non-linear behavior is a very important thing. Since linear behavior only in the Hooke's law will come into picture, the stress is directly proportional to strain. So within that only we can approach the elastic approach. But if for a non-linear behavior material, composite material, so we cannot adapt this kind of elastic approach. It's a thing for very important limitation or challenge for this. As well as the damage failure, then material variability. Material variability means same thing. The elastic approach, the elastic property may affect when compared to when have a material variability. So by understanding the elastic approach in composite materials, we can predict the elastic behavior of composites and design structures that optimize the stiffness and strength. However, it is important to consider the limitations of this approach and use more advanced analysis methods when necessary. So these are all things that in today's class we have discussed for elastic approach. What is elastic approach? What are the things has to be analyzed here with respect to the elastic approach? What is the assumption here? And then key aspects. Then what are the elastic properties, analysis methods, then limitations of elastic approach. Finally, the conclusion. Those things we have discussed in this class. Okay. We can have another topic with a different methodology in another class. Thank you for joining this video, and we can have another topic in the next class. Thank you and all.